Are we positive this isn't factorable? 15, 1 and 15, 3 and 5. Yeah, no, okay. So we have to do the quadratic formula because it's not factorable. So A equals 5, B equals 7, C equals negative 3. This part's going to be easy. I'm just going to fly through this. What was your discriminant? 109. I believe you. Okay. And then you got your decimals for that? Okay. So negative 7 plus the square root of 109. Oh, yikes. You have the numbers? I know, I'm just going to audit you. Just to be sure. Did you get 0.34403? Okay. So before I do this, normally if it's an x squared, an x, and a constant, this is what x equals, right? But because these are tangent squareds and tangents of x, this is what the tangent of x equals. So the two decimals that you will get when you do the negative 7 plus root 109 divided by 10, it's crazy long, and I'm going to keep that on my calculator. And then we'll get a second one when we do negative 7 minus root 109. But I'm going to focus on just one for a second, okay? So this is a place we get to in every single problem. Tangent or sine or cosine of x equals a number, right? If it comes from our table, we can just grab the reference angle just from considering our red unit circle or your memorized values. If it doesn't come from your table, you have to use a calculator. And the calculator is going to help us identify the reference angle only. Not the answer necessarily, but it's going to give us the reference angle. Right, so I'm going to do inverse tan of that number. And it says between 0 and 360 for this section. So my calculator should be in mode degrees. So I had to switch mine. But then I can do inverse tangent and scroll up and grab that number exactly as is. You don't want to round that number because that's going to affect your angle. It'll be off by a degree or two. And we're going to round that reference angle to the nearest degree. So that is 19 degrees. And then with that reference angle, we have to decide which two quadrants are we in. This is when tangent is positive, right? So all students take calculus. What are the two quadrants where tangent is positive? First and third. So a reference angle of 19 degrees in quadrant 1 will be an answer of 19 degrees. And a reference angle of 19 degrees in quadrant 3 will be 180 plus 19, 199. You're good. So that whole inverse process, whether you're doing it mentally with that red chart on the board or if you're doing it with a calculator, that only gives you information for the reference angle. That does not necessarily give you an answer. Here, 19 coincidentally was an answer. But had this been tangent equals negative that number, and our reference angle still would have been 19, our calculator would have shown negative 19, but our reference still would have been 19, it would have been a second quadrant and a fourth quadrant version. And we're going to see that probably over here. Right, so if I do, now I have to do my second answer. This came from the negative 7 plus root 109, negative 7 minus root 109, and then take that answer and divide by 10, negative 1.744. I'm going to do inverse tangent of that number, or I use the answer key, but you guys can go up and scroll. I get negative 60. What is the reference angle if, and I'm going to write reference angle so you know that this is not an answer. What's the reference angle of a negative 60? 60. And so if we think about our quadrants and try to grab our angles accordingly, tangent is negative in quadrant 2 and 4. So if the reference angle is 60, what angle is the answer? 120. Right? 180 minus that 60. And how about this one? 300. Right? 360. Back it up. 60. 300. Beautiful. Okay. You like those? Okay. Well, it's funny to hear you guys say that. Yes, but only if it's an inverse cosine would I be concerned. Here's what could trip you up. If you, and this is any problem, whether it's a quadratic formula or it's factoring, if you get that the cosine of something equals a negative 0.8, we'll say. If you do inverse cosine on this, your reference angle is going to be a little bit tougher to figure out. And it's only going to happen with inverse cosine, and it's only going to happen if it equals a negative. So if I do inverse cosine of negative 0.8, here's what my calculator is going to tell me. That is not a reference angle. Right? Reference angles have to be between 0 and 90. The reason for that is because inverse cosines, particularly when cosine is negative, inverse cosines are limited to quadrants 1 and 2. So because cosine was negative, and it wouldn't affect if cosine was positive because it would have given me a first quadrant answer, it gave us 142, 3. What is the reference angle? Right, the difference between 180 and 143, which is 37. So that's tricky because your calculator is not giving you the reference angle. It's giving you enough information to figure out your reference angle. And actually, now if we go to set this up, where is cosine negative? 2 and 3, right? So 180 backed up 37 will actually give us that 143 answer. But 180 forward 37, you're not going to come up with that angle unless you've processed the mentally that there was a 37-degree reference angle. So 180 plus 37 gives us 217 would be our two answers. But that's not, like you said, is there anything tough about that? Like that cosine equaling a negative and having to think backwards about the reference angle, that's going to happen no matter what type of equation it is. That's going to be a special thing to think, remember why you're not getting a reference angle on your calculator. Okie doke. The other ones that I think are tricky, and for a different reason, are anytime your sine of x equals 1, let's say, or if your sine of x equals negative 1, or if your sine of x equals 0. And same with cosine of x, but we'll just focus on the sine of x. If you look at your red circle over there on the whiteboard, there's only one spot where the y coordinate is 1, and that's at what angle? 90 degrees. And there's only one spot where the sine is the extreme negative 1, and that's at 270. So understanding situations where there's only one answer, 0 still actually has two answers, right? When does that happen? Zero degrees and 180 degrees. So be careful of those special things. Be careful and I think we're all good at this point, but what happens if you get sine of x equals 3? Stop, right? That's a gift because you can just say no solutions come from that. On the flip side, cosine of x equaling 1, cosine of x equaling negative 1. Where does the cosine of x equal 1? 0 degrees, right? That's where your x coordinate equals 1. Where does cosine of x equal -1? 180. And where does cosine of x equal 0? Perfect. So those, I guess, JR, would kind of be special, like a little bit different as well, because there's not really a reference angle to work with. I mean, there is. This technically has a reference angle of 0, but you only grab one side. And that technically has a reference angle of 90, but I don't usually think of it with like the rest of them. Okie doke. Okay. Just from the reference sheet, something like this, or the review sheet rather. What would you do first here? Move the 1 over. Good, Brock. Then what? Square both sides. So that's just making, like, that's just capitalizing on like your understanding of, do you know how to solve a radical equation first? And then you're just going to isolate your tangent like everything else. So subtract your 2 over. Divide your 4 over. And then what are you going to do from here? Inverse tangent, right. So inverse, and this will give us the reference angle only. Inverse tangent of 7/4, 60-degree reference angle. So I'm writing down reference angle equals 60. And then I have to find the 2 appropriate angles for the 2 appropriate quadrants where tangent is positive. Yes? First and third. So 60 degrees and 240. We got it? It's coming to you. All right, good. Good, good, good. Just in the nick of time. Number 6. Thoughts? Okay, Maddie said subtract cos of x. Andrew, what'd you say? Double angle. If you see cosine of 2x or sine of 2x, double angle. Okay? You got to choose the right one, and since the rest of the formula is written in cosines, when you're choosing, I would choose this one, right? Because that's keeping it in cosines. So I'm keeping the 3 there. I'm replacing this with 2 cosine squared of x minus 1. So Maddie, you weren't wrong. We will eventually subtract that over. Because why? Did you bring the cosine over and then factor or something? Let me steal. You can't when it's different. Like if you have the cosine of 90 and the cosine of 45, you can't take out a GCF because you're taking cosines of different things. You just erased it all? Right, so what she did and what I'll tell you can't do is she combined like terms. Same reason you can't factor because you're taking cosines of different things. You can't combine like terms. Cosine of a 2x is different than a cosine of x. So she subtracted her cosine x over and just treated it like it was 2 cosine of x. It's lucky. It's lucky. And I would see that transpired through the wrong, like a false process. All right, so you would just distribute, and then this would turn into a quadratic one where we're going to decide, can we factor or do we have to do the quadratic formula again? So subtract your can you factor? Yeah, and if you can factor but you choose the quadratic formula, by all means, that's fine too. So are we good to move on from this? A factoring one, are we good with? Secant of x plus 2. So the secant of x equals -2, right? Which means the cosine of x equals what? The reciprocal. And there you are. So if you see a secant or cosecant one or cotangent, cross multiply. There's a way out of that. You could just cross multiply your way out of that. But ideally, if you're trying, you can't do inverse secant on your calculator. That's the struggle, right? So anytime you have a reciprocal function, you can still isolate it. Once you've isolated it, though, change it into its reciprocal function. Mike? Okay, so 5, because there's a combo of tan and cotan, my first step would probably be to change this into 1 over tangent, which will make it 3 over tangent. Do you follow? And then I'm going to multiply everything by tangent to get rid of that. So if you multiply, because you don't like, we should not like denominators, right? So if I want to clear this divided by tangent, I'm going to multiply this side by tangent x and this side by tangent x to clear that. So the left will become 2 tangent squared. And then on the right, because it was a binomial, I have to distribute that tangent. So tangent of x times 1 will be tan x. And the tangent of x times the fraction will just cancel that tangent, and it'll just be plus 3. And then it's a quadratic like everything else. Here's another option I will give you if you feel like we never did this. We did. I might have just taught it differently the first time. I don't remember. But if I do that same thing and make it 3 over tangent, just like rational functions in algebra 2, if you get a common denominator all the way across, so put this over 1, put this over 1, give this a tangent and a tangent, it would be 2 tan squared. Give this one a tangent over a tangent, it will be equals tangent, and then plus 3. If you give these all tangents to get a common denominator, once you have a common denominator everywhere, you can drop it, and it's the same quadratic we got from doing it the way I just did it. Does that make sense? So whatever you like better. So that would be factorable or not? Yeah, that's factorable. We have to subtract some things over first, but it will be factorable. You'll factor it, you'll tee it up, you'll find 1 or 2 solutions for each piece. 4 is a pretty straightforward quadratic. It's factorable. 3 is a pretty straightforward quadratic. I think it will also be factorable. And 2, you should look at and immediately see the need for a double angle, because you're taking the sine, cosine, or tangent, who cares what it is, of 2x. So this would be replaced with 2 sine x cosine x, minus the cosine x that's already there. And then what method would you use to complete this? Quadratic formula? No. GCF. Yeah. So you take out a cosine x. You're left with 2 sine x minus 1. And then you'll tee this up and you'll tee that up. So you'll get cosine x equals 0. And the sine x equals a half. And these are like side by side. I treat these two differently. For this second one, I would come up with a reference angle. And by the way, just so we're reviewing, this is radians. So if you do it on your calculator, you're going to get 30 degrees, which is how many radians? Pi over 6. So your reference angle is pi over 6. And sine is positive in quadrants 1 and 2. So the first quadrant angle is the pi over 6. What's the second quadrant angle? What'd you say, Maya? 5 pi over 6. Because it has to be 1 pi over 6 prior to 6 pi over 6. 6 pi over 6 backed up 1 pi over 6 is 5 pi over 6. And then this one I'm really going to do based on where's the x coordinate 0 on my unit circle. Pi over 2 and 3 pi over 2. So you do have 4 answers there. Good. I have quizzes to give back. This was just that little quick quiz. Will you pass it back for me? Yeah. Please. Please and thank you. There you go. Tori and Tommy, I'm going to take a minute and grade yours right now.